In this video, we're going to learn about the laws of exponents. At the end of the video, you should be able to simplify or evaluate expressions that involves exponents. As a simple example, you have an expression 3 to the power of 4. It actually means 3 is multiplied to itself 4 times, and this value is equal to 81. So far it looks pretty easy, but there's a lot of properties involved. What is exponent? In this expression, 5 is actually called the base and your 3 is actually your exponent. Here you have an example of 125. This actually can be written as an exponential form, 5 with an exponent of 3, which means that 5 to the power of 3 is an exponential form of the number 125. 5 with an exponent of 3 means 3 is the number of factors of 5, which means 5 is multiplied to itself 3 times. Okay, now here are the different laws of exponents. We have the product of powers, quotient of powers, power of a power, power of a product, power of a quotient, negative exponents, and zero power. Let's start with the first law. The product of powers. If you are multiplying powers with the same base, keep the base and add the exponents. Keep the base and add the exponents. Here is your guide. You have x to the power of m times x to the power of n. You just actually keep the base and add your exponents. Example, you have here 2 to the power of 6 times 2 to the power of 3. You just actually keep 2 and you add the powers 6 and 3, or the exponents 6 and 3. So you have 2 to the power of 9. If you are going to evaluate further, 2 to the power of 9 is 512. It's the way it is. You just keep the base and add the exponents. Now let's have your second law. You have quotient of powers. When dividing, the first one was multiplying. When you are dividing powers with the same base, you keep the base, but you are going to subtract the exponents. Here's your guide. Here's a division. When you divide, here's a fraction form of division, and you have your arithmetic form. When you divide, you actually just subtract the exponents. The first exponent is written minus the second exponent. So here's your example. If you have 2 to the power of 6 all over 2 to the power of 2, you just subtract your exponent. 6 minus 2 is 4, and then you evaluate further 2 to the power of 4, you have 16. And that's how you divide. When you divide, you subtract exponents. Let's have your exercise. We have here your 10 exercises. And let's check the solution, or let's try solving them together. You have 3 to the power of 2 times 3 to the power of 2. Remember, multiplying, you add your exponents. 2 plus 2, you have 4. 3 to the power of 4. 3 to the power of 4 is actually simplified as 81. Next, you have 5 squared times 5 to the power of 4. You just add 2 plus 4, 6. 5 to the power of 6. You have a variable this time, a to the power of 5 times a to the power of 2. You have 5 plus 2 is 7. You can also read a to the power of 2 as a squared. Now, you have more terms involved. You have a number, a coefficient, and a variable. What do? You actually multiply your coefficients or the numbers. 2 times 4, and then of course the rule for multiplying is you add your exponents when you multiply expression with exponents. So the final answer is 8, and then 2 plus 7 is 9. You have a power of 9. 8s to the power of 9. Next, you have a negative 3 as your base. You just copy, keep your base, negative 3. You add your exponent, 2 plus 3, and you have 5. When you simplify further, you have a negative 243. Next, the number 6 is that you have two variables. You just separate s and t and add their exponents. S has 2 and 7. T has 4 plus 3. 2 plus 7 is 9. 4 plus 3 is 7. So you have s to the power of 9, t to the power of 7. That's it. Let's have the remaining. There's 10 exercises. This time it's division. When you divide, you subtract your exponents. So you have 12 minus 4. 12 minus 4 is 8. And that's it. Number 8, you have 3 to the power of 9 divided by 3 to the power of 5. 9 minus 5. It's 4. 3 to the power of 4 can be simplified into 3 times 3, 9. 9 times 9, 81. Next, now we have combined variables. You just separate them. Like when you multiply, you add your exponents. When you divide, you subtract their exponents. So you have s is 12 minus 4. 8 t is 8 minus 4. 12 minus 4 is 8. 8 minus 4 is 4. That's it. And we have the last one. Again, now this time we have numbers and combined variables. You just divide your number, 36 divided by 4, and then subtract your exponents. Here is the work. 36 divided by 4 is 9. 5 minus 4 is 1. 8 minus 5 is 3. And that's your final answer. 9ab cubed. If your power is 3, you can say b cubed. And that was your first two exponents, multiplying and adding. Let's have your next law. Third law is power of power. If you are raising a power to an exponent, you multiply the exponents. Here's your formula. If you have an exponential form and it is raised to another exponent, this time you actually multiply both exponents. Here is your first main example. You have 5 to the power of 3 and then square root. You actually multiply. It should be 5. No, it should be 6. Let me fix that one. No, it should be 6 because you are supposed to multiply. Okay. Next. Second is power of a product. If you have the product of the base is powered by the same exponent, the result is a multiplication of individual factors of the product, each powered by the given exponent. Here is your formula. You have two terms involved inside, so each term will have its own exponent from the outside. You distribute each term by that same exponent. Here's your main example. If you have a times b and both are squared, each will get a power of 2. When I take a power of a product, I apply the exponent to all factors of product. Here's your another power. The first one was a product. This time it's quotient. If the quotient of the base is powered by the same exponent, then the result is both numerator and denominator, each powered by the given exponent. So both on top and below will be powered by that exponent. And here is your example. You have 2/3 to the power of 4, each receives 4, and then you simplify further. 2 to the power of 4 is 16, 3 to the power of 4 is 81. So when you take power of a quotient, you apply the exponents to all parts of the quotient, to all parts of the fraction. each gets its exponent. Here are your exercises. There are 10. And let's begin with the solution. So, power of a power, you actually multiply. 2 times 5 is 10. That's it. Very simple. 3 times 4, 12. If you have 2 terms, each receives terms. Power of a product. 2 cubed and then 2 times 3. 2 times 3 is 6. 2 cubed is actually 8. Because 2 times 2 is 4. 4 times 2, 8. Here, there's 3, so each will be multiplied. Each powers will be multiplied to 2. 2 times 2, 5 times 2, 3 times 2. And then simplify further. And it's not done. 2 to the power of 4 is actually 16. That's it. Number 5, you have, so this is negative 3 will be powered by 2, and then a power of 2 will be squared. This becomes positive 9, and this becomes 4. And that's it. Number 6, 3 times 2, 3 times 4. You have 6 and then 12 as powers of S and T respectively. Let's have the next 7 to 10 on the next page. Next slide, you have quotient. Each receives the same power. So you have S to the power of 5 all over T to the power of 5. That's how simple it is. Now you are going to distribute 2 times 9 and then 2 times 5. Oops, what happened here? So there was a simplifying. 9 minus 5, it applied the second property, which is quotient. You subtract 9 minus 5 is 4. You can actually also do the other way, the quotient of power. It will result to the same final answer. Here you have 4 times 2 is 8. 3 to the power of 8 is simplified as, no, there's no final answer. You can use calculator to evaluate that further. Here you are going to distribute 2 to everything. So here we have, nope, again, 8 minus 4 is 4. So T was cancelled out. So this time you can now distribute everything with 2. The 4 times 2 became 8. The rest has an exponent of 1, so it becomes power of 2. And that's actually the final answer. So I guess we are going to simplify first. 36 divided by 4 is actually 9. 5 minus 4 is 1. 8 minus 5 is 3. See, before you're distributing your power. So you have 9 squared, a squared, 3 times 9 squared is 81. This is already simplified. 3 times 2 is 6. 81, and then a squared be 6. That's the second set of your laws of exponents, and there's more. We have the negative exponent. If the base is powered by the negative exponent, then the base becomes reciprocal with the positive exponent. Just to explain, when I have a negative exponent, I switch the base to its reciprocal with a positive exponent. If the base with the negative exponent is in denominator, it moves to the numerator and loses the negative sign. 5 raised to negative 3 goes down and loses positive sign. No, loses negative sign. 5 cubed is 125. If the exponent expression is under or it's in denominator, it becomes a numerator, or it becomes reciprocal 3 squared over 1 and loses negative sign. That's it, 9. You have your last, any base powered by 0, exponent equals to 1. Any expression power with an exponent of 0 is equal to 1. So whatever expression raised to 0, the answer is 1. That's how simple it is. Okay, every power has a coefficient of 1 if the exponent is 0. Let's try your exercises. And there are 10. Alright, let's begin answering them. An expression raised to 0 is 1. Now, this is negative. To write it without a negative, if it's a numerator, it goes down. So, oops, there it is. It goes down. What actually happened is that instead of applying the negative exponent rule, it applied the addition rule. 2 plus negative 4 is negative 2. Again, it used the very first rule, the multiplication of power by adding. Since you have negative here, then you can write it underneath. So 1 over y squared. Okay. Next, negative 1. So it's a numerator, it goes down. That's it. Here you are going to add 7 negative 2 is actually positive 5. I don't know. Yeah, and that's it. Next, you are going to distribute everything. Let's see how it's done. Yeah, so 3 has a negative 4. Negative 2 and negative 4, you multiply, it becomes positive 8. 3 times negative 4 is negative 12. All the negatives goes down. 3 to the power of 4 is 81. And then when you write it down, it loses the negative exponent. Y negative 12 goes down, loses the negative sign. Whatever you transfer, if an expression has a negative exponent, it moves from numerator to denominator, or it goes up and then it loses the negative sign. Let's have another. An expression raised to 0 is 1. Okay, let's have the last set. Now here, see how it goes. 2 squared is actually 4. And then, since there's a negative exponent, they switch and you just actually flip the whole expression and the negative sign disappears. That's a shortcut. Unless you want to write negative 1, and then you switch place and loses negative sign. This time, you are going to subtract 9 minus 5 is 4. And negative 2 times 4 is negative 8, and then it goes down. Next, you are going to simplify first. There's s squared and then t squared. 2 minus 4 is 2. So it applied the quotient rule. 2 minus 4 negative 2, 2 minus 4 negative 2, and then multiply both by negative 2. Negative 2 times negative 2 positive 4. Negative 2 times negative 2 is positive 4. That's it. You can actually use any rule, whichever you think will works for you. As long as you follow the rule, you'll get the same correct answer. And here's the last one. It's tough. We will simplify first your expression inside. 36 divided by 4. 5 minus 4. So here it is. 36 divided by 4 is 9 to the power of negative 2. 5 minus 4 is negative 2. B has a 5 times negative 2. It becomes positive 10. This goes down, 81, and then a squared. And that's the final answer. Okay. And that's it. You can review the video if you need to.